Madam, good morning. Punitha Valli Balabu, madam. Yeah, good morning to all. Very good morning to all.
Good morning, sir.
Madam, shall we start the section, madam?
Yes, sir. Yes, sir.
Yeah, Madhumita.
Good morning, sir.
Yes.
Good morning to one and all present here. We are now going to start the session. We are very grateful to welcome our respected Chief Guest, Dr. K. Kalayarasi ma'am of this session. The topic of today's session is fuzzy inventory model with machine learning. Now I call upon Mr. Ilavarasan sir to address the speaker. Thank you.
Good morning to all. I'm glad to introduce our resource person of this session, Dr. K. Kalayarasi ma'am. Currently, she is working as an assistant professor in the Department of Mathematics, Kaveri College for Women, Autonomous, Tiruchi, Tamil Nadu, India. She has obtained his degrees from reputed institutions and universities. Also, she is a gold medalist. Her area of research includes differential equations, fuzzy inventory model, and machine learning. She has 25 years of academic, research, and administrative experience in various reputed institutions. She guided more PG students and MPhil scholars. Also, she produced more research scholars. She has published more than 150 research articles in the reputed international journals like Science Citation Index, Web of Science, Scopus, and UGC CARE journals. Also, she is participated and presented huge number of research articles in the various national and international conferences. She has written a textbook and published 2 patents. Also, she is an editor and a reviewer in the various international reputed journals. She has acted as a resource person, technical committee member, and session chair for the various seminar, national and international conferences. She is also organized and actively participated in many workshops, webinars, and guest lectures. She was honored by the institution for her excellency and contribution in various fields, includes Woman Researcher Award, Young Scientist Award, and Young Woman Mathematician Award. We are very delighted to welcome you, ma'am, on this wonderful session of this online international faculty development program on current trends in applications of mathematics. Thank you, ma'am.
Thank you.
Yeah, now we hand over the section to Kalayarasi madam. Please
Yes.
proceed, madam.
Okay. It's visible. Screen is visible.
Yes, madam, visible.
Okay. So my voice is clear now, sir. It's audible now.
Yes, madam, visible and audible.
Okay. Thank you, sir. Thank you. So thank you for your nice introduction. Anyway, good morning to all. So today I would like to deliver the topic fuzzy inventory model with machine learning. So first let us see what is fuzzy. So it was introduced by Lord Pizzordi in 1965. It is an extension of the classical notion of the set. And Zordi introduced a mathematical method which involves the decision making using the fuzzy descriptions of some information it becomes possible. And fuzzy means like a vague, and fuzziness occurs when the boundary of the piece of information is not clear cut. And let us consider the fuzzy set. So fuzzy set is like these elements have degrees of membership, and it permits membership function values in the interval of 0, 1. So it always lies, it takes an element between 0 to 1, which represents the degree of an element belongs to the particular set. It's like a membership value. And it has been shown to the useful tool to describe situations in which the data are imprecise or vague. And fuzzy sets handle many such situations by attributing a degree to which a certain object belongs to the set. And it is a classical set theory. The membership of the element, it exists in binary terms according to the bivalent condition. And fuzzy types of presentation is nothing but is in linguistic and decision-making, knowledge representation, medical diagnosis, control systems, databases, we can use like fuzzy types of presentation. And is a special of fuzzy number, it is an interval. And let us consider the fuzzy set and the twist set. So what is the special quality in the fuzzy set element? It's like ambiguous, it contains ambiguous properties, and the elements are allowed to be partially included in the set, and it is used in the fuzzy controllers, and it takes only like infinite value. And next, let us consider the concept inventory. So all you people who are very familiar with the inventory model. Now, what is inventory? So just I would like to tell the basic things. So inventory is like it refers all the items, goods, merchandise, and materials held by the business for selling in the market to earn the profit. So it is the component parts and raw materials a company uses in the production or sale. Inventory refers to a stock in various production stages, and it is like a current asset. And the main function of inventory is to provide operations with an ongoing supply of materials. And the inventory characteristics includes how much inventory to order, the order cycle. So that's very, very important to place the orders, how far in the product. And next to the quantity of the product, the business asset in hand appears on the balance sheet as an asset. So companies maintain the inventory need to know how much of it, and they have how much it's worth. Everything we should identify. So the knowledge of the inventory makes it possible for the company to plan efficiently when it comes under the process. So this is the sample of inventory balance sheet. So it contains what is the current assets. For example, cash and cash and account receivable as well as the inventory and prepaid expenses. So this is the example. Just I would like to show what is the inventory balance sheet. Okay, next let us consider the concept EOQ, that means economic order quantity in inventory model. So it refers to the ideal order quantity that company should purchase in order to minimize its inventory cost. So it is used in the inventory management, which is the oversight of the ordering, storing, and use of the company's inventory. Next, let us consider what is economic order quantity. It refers to the best order quantity to make the total cost minimum by considering the balance between the ordering cost and the inventory carrying cost, which are contradictory. So we have to balance both the cost. Next, the economic order quantity is a very, very important role, and it helps the companies manage their inventory efficient manner. And without inventory management techniques, the company will hold too much, and that means inventory during periods of low demand and holding too little inventory in periods of high demand. Next, we have to combine like a fuzzy, because till now what we have seen. So what is fuzzy? And I have given some inventory basic definitions, everything. Now this is the connection between fuzzy inventory. So the inventory models in the fuzzy sense, in which the ordering cost and holding cost are represented by fuzzy numbers. Not even ordering cost and holding cost. So what we considered in the total cost, like demand and setup cost, so like a purchase cost, so all the things we can consider like a fuzzy number. So fuzzy set theory is a research approach. It deals with the problems relating to the ambiguous and subjective and imprecise judgment, and it can quantify the linguistic facet of available data, and it is like an individual, either it's like an individual or group decision making. So this is like the process. So what is the process? How far it's like actually we will go through with a material collection. It can be converted into the descriptive analysis. That analysis actually we have to categorize the selection basis. After that, again the material evaluation has to be done. So the deterioration rate, demand, holding cost, unit cost, and salvage value are taken as like a trapezoidal fuzzy number. Because we have two concepts we should know. So one thing is defuzzification. The another thing is like a fuzzification. So whatever the crisp quantity, we have to convert into fuzzy numbers according to the through membership. So that is called the fuzzification. And it's like a defuzzification is nothing but is a process of splitting, okay, into that means fuzzy to crisp. So that is like a defuzzification. So here next we have to consider the concept machine learning. So this is the latest trend actually, because it's like one roof under all the things. No, it come under one roof. It means like artificial intelligence. It's like a data science. Everything together. It's like it's the latest technology is nothing but machine learning. So we have done already almost research in fuzzy inventory models, and now the recent approach is nothing but fuzzy inventory models with machine learning. So it's a very nice approach to maybe produce so many outputs and so many applications oriented. And it is a branch of machine learning, is a branch of artificial intelligence and computer science, which focuses the use of data algorithms to intimate the way that humans learn, gradually improving its accuracy. And it is an important component of the growing field of data science. And it is a data analytics technique. It teaches the computers to do what comes naturally to the humans and animals. And it uses computational methods to learn information directly from the data without relying on the predetermined equations as a model. And next, let us consider, because before going to the applications of the fuzzy inventory models with the machine learning, we should learn little bit, or we should know little bit the importance of machine learning. So where and all we can use like machine learning in like applications, in real life applications. So it's very important because of its wide range of applications and its incredible ability to adapt and provide solutions to complex problems very efficient manner. And that algorithms utilize a variety of techniques to handle large amounts of it. Maybe large amounts in the sense it's a lakhs together or crores, whatever the data, let it consider. But we can consider through machine learning, we can easily process that data. And these algorithms completely the task of learning from the data with a specific input given to the machine. And it's important to understand the algorithms and the machine learning system as a whole work, and it can get know how this can be used in future. So these are the main applications of machine learning. So we can use like machine learning in automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, and email spam and malware filtering, and self-driving cars, product recommendations, and traffic predictions, and speech recognitions, as well as image recognition. Next one, machine learning in real life applications. So it's a very nice example of the applications. It's like an image recognition. So we have to consider the classification. So under that, we have to use like a classification technique plus that localization. So we can detect that object in clear way. So we have to consider the label in the X-ray, as well as we have to assign a name to the photographed face, as well as the recognize the handwriting by the segmenting the single letter into the smaller images. So this is the process here actually to apply in the image recognition process. So next one, speech recognition. So machine learning translates speech into text. So it's like it plays a very important role to convert this speech into text. And many software applications can convert the live voice and recorded speech into a text file. And it contains like a voice search and voice dialing and appliance control. So this is the process actually I have figured it here. So the input, suppose if you say like a hello. So here actually that process we have to apply that neural network. So neural network contains like many we can apply the falsification techniques, all the reflexification techniques like this. So corresponding to output actually we have in the text like form is a hello, HELLO like that. And next, medical diagnosis also we have to use. It helps with the diagnosis of diseases. So many physicians use the chat box with speech recognition capabilities to discern pattern in symptoms. For example, assisting in the formulary diagnosis or recommend a treatment option, we can do it. And oncology and pathology using machine learning to recognize the cancerous tissue. So this is actually really here I would like to tell one thing, because many projects, for example, SERB level projects, it's like a DST SERB and DST now sure also. So many funded agencies, they actually were preferring a sustainable based kind of applications. So actually that this fuzzy logic actually we have to use fuzzy logic with the machine learning. It's like a newly introduced in my research only in 2020 onwards I have started research in this fuzzy inventory model with the machine learning. So many applications we have derived and we have applied for the projects, funded projects also. And the next one, the statistical arbitrage we can use it. So arbitrage is nothing but is an automated trading strategy that is used in the finance to manage a large volume of securities. So the strategy uses the trading algorithm to analyze a set of securities using economic variables and correlation. Here, whatever the examples I have taken, because before the 3 examples we have seen, correct, in the medical diagnosis and speech recognition as well as image recognition. Okay, the fourth one is the statistical order page. Because here this is not a time to tell all the things, but at least I would like to tell these are the applications, and we can do many research and many articles in this area. And maybe we can apply for the projects also, 100 projects. So it's like because full this applications oriented. The only other thing we have to learn machine learning techniques. That's all. And next, algorithm trading. This analyze the market microstructure. So it's a very, very important in latest scenario. And that analyze the large data sets as well as the identify real-time arbitrage opportunities also. Next one is the predictive analysis. So machine learning can classify available data into groups which are defined by the rule set of analysis. So the classification is complete. Then analyst can calculate the probability of the fault one. So it's a very, very important role in real life. So predicting is one of the most promising example of the machine learning. So the prediction is very, very important nowadays, correct? So predicting whether the transaction is a fraudulent, we can easily identify the fraudulent cases, everything. And we have to improve the prediction systems to calculate the possibility of fault also. So the next one is extraction. So machine learning can extract the structured information from the unstructured data. So machine learning, that algorithm automates the process of annotating data sets for predictive analysis tools. So it can extract or it can track and extract information to obtain billions of data samples. So this is the main advantage. So next, generate a model to predict vocal cord disorders also. It helps physicians diagnose and treat the problem in a very quick manner. So next, let us consider the types of machine learning. So machine learning is like a very, it's a very broad area, but it can be divided into 3 main areas. That is, first one is like a supervised learning, unsupervised learning, and reinforcement learning. So these are the types of machine learning. So that supervised learning under the task driven, it means like the mathematical concepts like a classification, regression we can apply. Next, unsupervised learning under is the data driven. So K means cluster. So like that, these are the techniques we can apply under unsupervised learning. And similarly, reinforcement learning, learning from mistakes. So for example, we're playing games and all. So we can, in this type of category, it will come under reinforcement learning. Okay, first let us consider one by one. It's like a supervised learning. So this is the machine learning task of learning a function. It maps into input to the output based and or the example of input and output pair. And next it is this algorithm analyzes the training data and produces an inferred function which can be used for mapping. Next, supervised learning is typically done in the context of like a classification. So if we want map input to output labels, or we want to and input to the continuous output also we can give. So this is I have given some examples about supervised learning. See, input raw data. So I have given some raw data. It's like I have taken the fruits. Okay. So mango is there and some like apple is there. So many variety of fruits are there. Correct. So randomly I have given some fruits categories. Correct. Okay, so now supervised learning, it's like, I have to give some number of raw data. It's like a training set as well as like a desired training as well as a testing like that. And we have to apply the corresponding algorithms. Okay, so here I have used like a Python coding here. And I have to apply the process, even fuzzy also I have to apply here, classification and declassification in all the categories here we can apply. And we have to, here with the process, all the process here machine learning. So we have to create the corresponding algorithm. So after that, we have to use the algorithm to create the process part. After that, we just see the final output. So what are because all the categories are there, correct? So here actually we have to categorize like that apple and peaches and like that mangoes like that. So the supervised learning is the process of providing the input data as well as the correct output data to the machine learning model. So the aim of supervised learning algorithms to find the map function to the map input variable and the output variable. Next, let us consider the classification. So it is the process of categorizing the given set of data into many classes. So it can be performed on both structured or unstructured data. The process starts with the predicting the class of given data points. And that more often it refers as a target and label and categories like that. Next, let us consider the statistical concept like regression. So regression in machine learning consists of the mathematical method. It allows data scientists to predict the continuous outcome based on the value of one or more predicted values. And it is used to predict the continuous value also. And it is a supervised machine learning technique, and it is used to predict continuous values. And next, the ultimate goal of the regression, why we have to use the regression algorithm is because we can easily plot a best fit line on the curve between the data. And the three main metrics used to evaluate the trained regression model are variance, bias, and error. Next, let us consider that under regression, this is one part of this is linear regression. So linear regression is one of the easiest popular machine learning algorithms. It is a statistical method and is used for the predictive analysis. And it makes the predictions for continuous or real numerical variables such as age, salary, age, product price, etc. So we can consider many attributes also. Next one, logistic regression. So it is also, this algorithm is actually based on the concept of the probability. And it is used to predict the categorical dependent variable, and it uses a given set of the independent variable also. So logistic regression predicts the output of the categorical dependent variable. And next, unsupervised learning. This is like another type of machine learning. So till now what we have seen, it's like a supervised learning. Under supervised learning, we have considered like regression, linear regressions like that. Okay. Now let us consider the unsupervised learning. So this is the type of machine learning in which the algorithm is not provided with any pre-assigned labels or scores for the training data. And it is a machine learning technique in which the users do not need to supervise the model. So the main goal of unsupervised learning is to discover the hidden and interesting patterns in unlabeled data. So the methods cannot be directly applied to the regression or the classification problem, as one has no idea. So what the values for the output might be. So we can apply, we can go for this unsupervised learning. So in the unsupervised learning in machine language, in the sense, so input data I have given like that. So this is the model, like a supervised learning. So here all the technique we have to apply, coding, everything. So what is the output? See how it's categorized in the way. So clustering is an unsupervised machine learning task that automatically divides the data into clusters or groups of similar items. So what are the similar items? So because we have many fruits or the apples, all those things, peaches, everything is there. So it like segregate one by one, like so apples and all. So how many apples like that? So it's like we can use like a fuzzy C-means cluster. So fuzzy C-means cluster is a very nice technique to detect all kind of even the brain tumor and like brain hemorrhages, those things, so to find those things. So how much we can optimize everything, we can find out easily using this machine learning technique. So unsupervised learning does not use the training data. So only it takes like, it does not use in the sense training data. It's like a partial use, not like because supervised learning only we have to split it like a training data for some percent and testing data like that. But here unsupervised learning is not required. Next, the third one is reinforcement learning. So this is the machine learning training method. It based on the rewards desired behaviors and the punishing undesired ones also. In general, it is a reinforcement learning agent. It's too able and it interprets the environment, and we can take the actions and learn through trial and error better. And it is a subset of the machine learning. It enables an agent to learn through the consequences of actions with specific environment. And reinforcement learning is the process of running the agent through a sequence of state action pairs. Also, it observes the rewards that result and adapting the predictions. So this is the reinforcement learning methodology. So we have to give the input raw data. The reward as well as state and action we have to take, and we have to select here some algorithms related to the what actually we are very familiar like that, and through the agent, and we have to do all the what the coding, because each and every part we have to apply the coding. That's all. So we have to learn the coding part. After that, just once the process gets over, it like we will get the corresponding output like in this way. So this is the what is a flow chart of reinforcement learning technique. Next one, just let us consider the concept. What is like a prediction? So how far that machine learning it applies in the prediction? So prediction means what? It will happen in the future, correct? So it gets based on the facts or evidence, but not always. So the future events are necessarily is like uncertain. So that's why we are using like a fuzzy here. So guaranteed accurate information about the future is impossible, right? So it refers to the output of an algorithm after it has been trained on the historical data set. So we can use like a machine learning. Predictive analysis can provide answers with confidence level. So just like percentage, so even like a 95% of confidence level was like 99% of. So that's why we have give some set of values to the training as well as testing. Next one, linear discriminant analysis. So what is linear discriminant analysis? It's like a supervised classification method, and it used to create a machine learning model. And this model is based on the dimensionality reduction or used in the application such as marketing predictive, we can use it, and image recognition among other also. So recognition isn't image and what that's speech recognition. So all the recognition we can use. Next is the dimensionality reduction technique. So that's a very more important compared to other analysis part. So it's like a primarily used here to reduce the number of features to more manageable number before the classification. Next is another important one is name-based method. So it uses a similar method to predict the probability of different class based on the various attributes. So the algorithm is used in text classification, the problems having the multiple classes. So it's based on full like a probability models. It incorporates strong and independent assumptions. So naive-based classification algorithm is a probabilistic classifier. So it's easy and forced to predict the class of test data set. So it performs well in multi-class prediction. So in general, so which the complex data means we can use it naive-based. We can go for that naive-based algorithm. Next one, learning vector quantization. So learning vector quantization is a type of artificial neural network which also inspired by the biological models of neural systems. So any biological related thing, we have to cluster the formation where we have to optimize the thing so we can go for this learning vector quantization. So it is a classical quantization technique from the signal processing. It allows the modeling of the probability density functions by the distribution of the prototype vectors. And next, we can consider the k-nearest neighbor. So it is like the complete. It completes the most accurate models because it makes a highly accurate predictions. And the KNN algorithm is like a simple algorithm. It stores all available cases and classifies the new cases based on the similarity measure. And this is used to solve both these classification and regression problem statements we can consider. And K, because in short form, we can consider the K nearest neighbor is KNN algorithm. In the training phase, just stores the data only. That's all. When it gives the new data, then it classifies the data into category that is very similar to the new data. Next one, support vector machines. So a support vector machine is a machine learning model that is able to generalize between two different classes. Is a set of all labeled data and provided in the training set of the algorithm. So the main function of the SPM to check the hyperplane is able to distinguish between the two different classes. Now, so it's a very, very important like application because already I have applied these concepts into some proposed projects like that. So it's a very interesting model also. So first, let me explain what is like optimization of the average monthly cost of an economic order quantity inventory model for deteriorating items in the machine learning using Python. So I have applied the coding notes, the language we have to, because in machine learning, it's like a easy accessible. Why I have selected this Python language is it's a very easy accessible language. So that's why I have taken, because coding, everything is like available in online. Okay, so we can, instead of that, like the installing like Anaconda, all those things and all, we can use like a collab also. So using the collab, we can like create the coding corresponding to. So now previously we have studied many algorithms like, okay, so that what I have used in future, this is the K nearest neighbor learning vector quantization I have used a naive-based algorithm and linear discriminant analysis, and before that this thing regression and logistic regression and all I had used. So this is a like kind of recap. So what are the things we have studied? Okay, now just we consider the main part of this thing. So inventory is related to, so now what is the concept I have taken here? So inventory is related to the decisions which minimizes the average total cost or maximize the solution of the average total. I mean, I think the profit, okay, to maximize the profit. So that profit in the sense what we are considered like economic order quantity model. So here, the inventory models that deterioration plays very significant role because if you like invest more number of money Okay, so we have to segregate the deterioration part, correct? That then only we will get some profit, maximum profit that also, correct? So the deterioration is defined as a damage, okay, to the inventory quality. So for example, we have the deterioration in the sense what we can consider like a food or medicine or vegetables or fruits, so or like a classified under this deteriorating. Right? In many stock disintegration issues of the real world, the decay phase of the certain thing might be influenced by other continuous things also. For example, depending on the situation, the influence of the weakened items can be reduced by eliminating them through this examination. Okay, so what purpose we have used this like the derivation to find the sense of basically because after applying the machine learning, we can find easily the derivation rate, so we can avoid that what is the typical kind of unavoidable situations. Okay, so that kind of derivation things and all we can segregate and we can avoid. We can so then only we can calculate the maximum number of profit. So that's why. Next, we can specify the model. It impacts the average monthly cost, and we here actually we applied the approach in the sense non-linear programming. So what is non-linear programming? Because general linear programming problems, so many methods we can apply. For example, simplex method, dual simplex method, and normal graphical method, normal solving method, so many methods. But here non-linear programming means some specific methods only available. For example, Lagrangian method, Hunteker method, and so many. These two are very familiar methods, Lagrangian and Hunteker. And we have to we have to apply these two methods to solve the specified model. In essence, what is the total cost we have given? So this total cost is a fully like a non-linear system. So to solve the non-linear system, we have to use Lagrangian method. In this, actually, we can apply for fuzzy also. So why we are using like a fuzzy? Because everything is like it's a precise value only. So each and every cost I'm considering in terms of fuzzy. Okay, to optimize the total cost. So why actually I have to apply fuzzy to optimize the cost level? Okay, because all the cost and all is like the imprecise data only, correct? So I had to from this data I have to get the maximum profit in the sense I had to each and everything I have to optimize. Okay, so I had to apply this technique and fuzzy concept also. And the fuzzy, actually we have to fuzzify the inventory model to determine the lowest cost by employing the trapezoidal fuzzy number. Because but the next question arises by how we have to convert into all the cost to the fuzzy. Doesn't like we have to use like a trapezoidal fuzzy and a triangular fuzzy and pentagonal, hexagonal, octagonal. So many fuzzy numbers are actually recently it's like many numbers also developed. So we have used like many types of fuzzy numbers for classification process, and similarly the declassification process also we can use like techniques like, for example, here I have mentioned that the graded median integration representation method or centroid method. It's a very famous like fuzzy logic in a sense, very famous method is centroid method. So we can use these methods and all to defuzzify. To defuzzify in the sense what? So fuzzy to crisp again, we have to convert the data into the corresponding output, correct? So that's why just we have used these methods and all. And next, to test the integrated inventory model, we have to apply the Python. So here actually I have used the version 3.8.5 because every time we have to mention, because it's updated versions, any new updated version means we have to mention that. So here actually in general I will use this 3.8.5 version only. So the code to predict that economic order quantity as well as the total cost. So before that, what we have to create the CSV file. So the CSV file, because every data in crores data you have to take, because the deteriorate items we have to consider all the costs. Okay, all the costs and all the costs of the item what I have considered, some 10 kind of different fruits you can take it. Okay, or vegetables you can take it. Whatever they be, just you can take of different types. So plenty of types and plenty of data, like a crores number of data I have taken. So everything just like that I through Excel sheet. No, I can't read like in the Excel sheet only. We have to prepare the data. But we have to convert into, because we are using like Python, we have to convert into CSV file. So final CSV file, final.csv we have to convert and use to describe the function. So we can find mean, median, standard deviation, and percentage. Everything the coding is available. So we have to use the coding, Python coding, and it will automatically it will generate these answers and all. Next, you have to test the model. So we have to, if you're testing the model, in the sense we have to split the given data as training. For example, how we can split the training and the testing is like 80-20 we can split like that, or 70-30 we can split like that. So we split the data into training as well as testing to predict the economic order quantity as well as total cost. Next, we have to use the training data set to split the data. Okay, so now what are the methodologies we have to apply for this? Here, actually, we have applied already. I have explained that what types of machine learning and all, correct? So here, actually, we can use linear regression. So find the root mean square value and R2 score also. So in the scoring, we can compare the data. So, okay, the derivative items, so how far it's damaged, everything. So finally, we have to summarize the values of the linear regression by using the ordinary least square method. So here, what methods actually we have mentioned previously? All the methods here I have applied here in this article. Actually, this is one application I have taken. So this is the Python code. What are the steps in general we should follow, and I have followed also. So first one, import the basic libraries. So what are the pandas library, or what are the necessity NumPy we have to take it. So what are the necessary codings, library, basic library codings, we have to take that. Next, we have to read the CSV file and display the first 5 rows, because, for example, but the CSV file, it contains stores of data or lakhs of data like that, right? So first we have to, for example, I have to test whether it like arranged the properly or not. So first display, for display purpose, I have to select that first 5 rows from the data set. Okay, so display function to view the statistical details. So every how actually the work, how it's behind. So we can see for that purpose we can display this one CSV file. Next one, scatter plot code we have to use for economic order quantity. Okay, next one, that main important machine learning model is like a logistic regression we have to apply. So to test the model, we created the CSV file that use the Python code. We developed the program, so that's very important, to predict the economic order quantity as well as the total cost. So this is the first 5 rows of data set, because I have taken like rows of here. Actually, I didn't insert the CSV file. So for that reason, just I have taken the screenshot of like first 5 rows of the data set. Here you can see very easily what are the items I have taken. See how it's segregate apple and all, like apple next to orange. So many items I have taken here. So the corresponding holding cost, ordering cost, purchase cost, fixed rate, as well as demand, and that coefficient, because in the total cost itself I have used the coefficient of variation. So I have taken that one, as well as the setup cost, that inspection cost, everything I have taken. So because randomly I have created already that the Excel file. So holding cost, it changes things. What is the corresponding total cost and economic order quantity? And if ordering cost, if I will change that ordering cost means what is the corresponding total cost and the economic order quantity. So similarly, purchase cost, fixed rate, demand, everything we have to take. We have to give randomly. We have to check it, and what is the corresponding answer for that? Whether it increases, whether it decreases, whether it's like independent or dependent. What is the correlation between the holding cost and the ordering cost, and the ordering cost and the purchase cost? So cost itself, we can find out all the things. So this is the main advantages why actually I use like machine learning means it's very easily we can recognize the cost itself, everything. Actually, we can easily analyze, and we can easily that correlate all the costs. So suppose if you like a holding cost comes down means what is the corresponding total cost and economic order quantity. So because the total cost depends upon the economic order quantity, it will change up and down, everything will come. No. So we can easily identify through machine learning. We can easily identify everything. So output also, we can analyze and everything. That output also is like a similar manner we can describe. So these are the statistical analysis I have used. So see everything that count. What is the count actually has? Next is the mean. What is the mean corresponding with? Because I have taken some lakhs together data. So here actually what is the corresponding mean I can find, and standard deviations, minimum, what is the quartile, what is the median, what is the percentile, and what is the maximum number of things. So everything we can easily get from machine learning. So scatter plot between the economic order quantity, other cost. Okay, suppose in the graph, whatever maybe how much if I will talk, okay, this is the difference, that is the difference. But the main part is the pictorial representation. So either to machine learning, using the machine learning, we can easily picturize all the things what is the variation between the economic order quantity and see here actually you can see the thing here economic order quantity and holding purchase cost and this one as well as demand ordering cost. These are the small samples I have taken and I compared the values of using the scatter plot. And similarly, the inventory model for the data-reading data items is studied in order to minimize the total cost and maximize the profit and solve for both crisp as well as fuzzy. Because here actually I would like to tell why actually we have solved in both cases. So crisp and fuzzy. So crisp means is like ordinary data. We have to consider whatever these cases and all holding cost everything as the same manner. The crisp data I'm telling. Okay, so here actually what is the corresponding total cost and what is the corresponding economic order quantity. So how the economic order quantity differs the total cost, everything just we have to using that hand calculation we can consider like what set of values. And you have to optimize this because whether everything is correct or not. And so we have to use the fuzzy technique. Okay, so fuzzy technique in the sense I have mentioned correct. So either you can convert all the crisp numbers to fuzzy numbers. Again, you have to do all the declassification and classification. Again, you have to regenerate the fuzzy to crisp like that. So is the declassification that we everything here. The main advantage is like all the models we are having so many methods available actually. So we have taken so many methods and for checking purpose also we can consider many methods. Next one, the fuzzy inventory model to solve by the non-linear Lagrange method because here Lagrange is like a one type of non-linear programming only. We can use like a Kuhn-Tucker and many other graded mean integration, many other techniques also we can use it. Moreover, we have to use the Python code to predict the values of the economic order quantity as well as total cost. So here, what is the result? Okay, I have done all the because here I'm not explaining in the depth way because I have given here like a time outline of the paper result. So what is the paper result? 98% accuracy is like original data what we have done as well as like through machine learning. So we have done some manipulations, everything, and we have used many coding. So what is the percentage of accuracy we got it here? 98%. So moreover, it's for checking purpose we can use like a machine learning to optimize whatever that optimization you can like a total cost and profit you can take, or sometimes to minimize the carbon emission in the greenhouse warehouse. So that also we can take it also with the real life problems, whatever the thing. Similarly, how we can optimize the brain tumor as well as like the AVM autoimmune small formation, the medical field actually we can tell. So medical if you go for the medical diagnosis analysis means we have to go for the instrumentation. So everything. So for separate instrumentation and also according to that we have to include and just we have to give the justification for that. So for what purpose there we have to include everything. But see here it's like a very big area because fuzzy is like a one type of area and inventory is like a operational result, that's like a different area. We have to connect first of all what fuzzy to inventory. Then these the techniques, these are the what actually we have applied the procedure everything into the machine learning. For machine learning, finally we have to check into the fuzzy inventory basis. So these are the main concepts. So this actually what we have mentioned is a one technique. So this is a one technique, one main application. This application we have like accessed some numerical through one numerical example because this is a numerical example what we have taken. Here I have given the statistical analysis and the graph also. So using like a Python code, we have solved the scatter plot. So that the plot itself, we can identify how far it's like, the connection between the economic order quantity and the total cost and the holding cost. And so if like change each and every the cost, okay, according to that economic order quantity will vary. That economic order quantity, because the total cost fully depends upon the economic order quantity. Right. So it's up and downs out there. According to that, we can do the conclusion. We can just be conclude. We have to reduce. Which one we have to increase. So everything we will get to know after. Okay. So next, let us consider the another important example. So this also actually we have done in the paper. or an optimization of the fuzzy inventory model for the trade credit policy for indebted consumers of the compliant. Actually, our aim is to reduce the carbon emission, to optimize the carbon emission in the total cost what we have considered. So first of all, let us consider. I would like to tell about like what technology behind this thing. So how far it's like fuzzy inventory model in the trade credit policy, indebted consumers of the complaint carbon emission. How far everything? Just I will explain how. So the awareness of the damages of the greenhouse gases is increasing, and it's led to the researchers to investigate the impact of carbon emissions. So that is the main part I have taken here. What is the impact? How much impact? And how far it is? So how to control the impact? Everything we will discuss later. So the impact of the carbon emissions in the operations management. So how far? So inventory control, it has been of the research areas. It attracted its attention in sustainable development because this is a one. Concept of carbon emissions is it will come under sustainable development. So as many processes emit carbon dioxide, correct, in the field of the operations to manage. So how to control the carbon dioxide, the carbon emission? So that we will see. So these are the methods. First of all, fuzzy inventory model with the carbon emission we have to develop. So this is like we have to consider like a total cost. After that, what we have to optimize this total cost. So this is the second process. What is the third one? We have to extend the credit period. While reducing the carbon emissions. Okay, for example, our target is like an annual period, 1 year target. Okay, so 1 year target fuzzy inventory model with the carbon emission. Okay, so every 1 month we have to give the level. Okay, the period that is called the credit period. Okay, so period while how we can reduce the carbon emission. So in each and every month, actually, we have to see it. So because of that, that optimization techniques is a very powerful tool to produce many results. Okay. So the next one, like optimization of carbon emission inventory model for indebted consumers. Anyway, because I can give only outline for this this session. Because it's like I will elaborate this thing means it's like a very huge area. But the main concept I can explain in very what is crucial manner and thorough manner, because here what are these results and all this diagrams and all I have showing correct to you. So these things and all already existing work. We have done these works and all. We have done the experiment, everything. Okay, so what is the output? I would like to share these things and all to this platform, because this is a very good platform. If I share these things and all, because many people you are listening, this is a new all what I have explained, because all like a fuzzy inventory models that and all already existing one only, because we have started this research like in 2008-7 onwards we have started, and before that also fuzzy inventory it's like developed in so many ways, and so many researchers also developed in all over the country. But here because why I got interested in this machine learning, because machine learning is a full behind full mathematics techniques only they have used. So as a mathematician, if we learn this machine learning, each and everything we can correct to ourselves. For example, it's a coding also. So what are the, for suppose, like as a mathematician, we know the concepts, correct? Regression means how we can control the regression, because with the linear regression analysis and all we have done, correct? So how far we can develop everything we will get to know. Okay, so it's very easy to handle machine learning. Okay, for the techniques, what is the how far it will reduce everything. So what is the thing we have to learn in the sense that coding, that's all. So Python coding, it's like I have told, it's like open access. So we can learn very easily, and or sometimes okay, maybe some people they will feel, ma'am, I don't have any computer background, and also how I learn for coding everything. See, MATLAB and all we are using generally MATLAB, and so many mathematical tools we have applied to solve many cases, right? The similar way, if you learn like a Python also is like see, by practice only we can learn many things, correct? So coding, suppose just a small program you take and you try yourself, and everything like it's like a notes, it's ready-made notes are there. So for the coding and all, no need to break your heads and all. So just like that, the coding you put in the Google search, you can do the corresponding coding, it will come. So use the code and you put it in the Colab, okay? Directly, Colab is like online, like, Jupyter notebook, like the Jupyter, you can, or work with a Spider, Jupyter under Python. So the same way you can use it for like a Colab also. So just you go apply the code and like you run the program. So what mistakes finally see first time itself, it's very difficult to get the results, everything. So we have to change the data. We have to, because already I told you we have given for testing and training. So change the percentage and change the library. What mathematical tools we have applied here? Actually, we can use like differentiation, integration, all the mathematical techniques and all we can apply that use machine learning. So that's why actually the main, because why I got very impressed with machine learning in the sense I also have attended some kind of FDP like machine learning and all in the COVID time. That time only I got very attracted this machine learning. So why we can't use that machine learning in our research area? So I have taught many ways. Finally, I got the path actually. Okay, so for optimization technique, definitely we can use like machine learning, and that also in my specific areas like a fuzzy control, fuzzy logic, we can use it. So finally, I got the nice output. All my papers, applications only. If in future also, if you people are having many doubts, you can ask. Then definitely the doubt will exist. Okay, so in future, if like you really you are very interested in this thing, and further you have to extract these things, definitely we will help. So we are the team actually. We are like each day, every day we will think one application. So many applications now it's going on. So and there's those applications and those outputs and those we make it into the granted the patent also. So we have applied for this like a patent. We can use a grant pay whatever may be. It's like a grant patent or whatever that patent we can do it. And the patent we have to elaborate that concept into some paper and project. So many real life applications. So that's why I have taken this kind of concepts. Okay, now. See, this is the crisp case also. I have shown this diagram as well as the fuzzy cases also. So how far it's like, total cost and this one, the normal crisp case, how far it will be the graph, and if you like after applying the Python coding and all, so how far in the fuzzy case. So how that total cost everything. So we can optimize both the cases. Next one. Like a Python mesh analysis, we can do it. Okay, so a mesh plot is like a 3-dimensional surface plot with no face colors and solid edges. So here actually I have used the coding like Python. So using Colab only I have done this mesh analysis. That is a very interesting and it's like very innovative also. So the image output from the Python for the 3-dimensional mesh. So what type of we have to fix the total cost and what economic order quantity. So both the cost we have to fix in one axis. Either you can consider like x-axis or y-axis. And one more axis we have to change on the ordering cost, because earlier I had told you what cases we have considered. All this is what cost and all we have considered. We have to keep on change. That is third axis you have to consider. And the function optimization is a process to determine the input. It provides the optimal output for the corresponding objective function. So this is the diagram. And finally, so I would like to conclude the basic thing. This is the model for fuzzy is a maximum integrated total reduction means reducing the cost, and it employs the fuzzy parameters as a decision variable to develop the carbon emission of the inventory model. So what actually here I'm not mentioning any data everything, but already we have collected because it's a common thing only. So carbon emission means it's a greenhouse, some manufacturing part. So in some specific part we have actually taken. In that part we have applied these techniques and all. So from that we have to develop the carbon emission inventory model like this. And as a result of this policy, to maximize the credit period, while the carbon emission, how far it is reduced, we can describe. Next is the evaluation among the elevated risk instances of the fuzzy model by using the mesh analysis. So here actually we have applied the mesh analysis Python. So and I would like to tell one more thing in the logic. So this is one kind of. And here actually I would like to this weighted items. Here you can consider like all the items in the sense fruits. Okay, so fruits, everything we have taken. Here I have mentioned some fruits and all. So like that, we had considered many number of different categories we can consider. And here I would like to tell the support vector machines. Okay, so support vector machines. Excuse me, just a lot of disturbance. Thank you. So that the support vector machine is a machine learning model only, but this is an all no in future actually we would like to plan to approach these algorithms, support vector machines, everything for checking purpose. Also, we can use like in the find maybe like many higher level concepts. Here actually k nearest neighbor also. These are not like very easy accessible algorithm. So what I would like to suggest. So k nearest neighbor and the learning vector this quantitation and naive Bayes algorithm. Next one is the linear distributed analysis. After that, these are the things and all. For what purpose now we can use it in the sense like prediction. So everything's like a prediction. So prediction we can't do it like full accurately like that, but at least for some certain level we can do all the things. And one more interesting here actually I would like to mention. Now recently we have applied some project in the sense I already told in the biological field. So that arteriovenous malformation. So arteriovenous malformation it's not curable. It's not like a disease. Okay, it's like a brain tumor. It's like that. Is a kind of the arteriovenous malformation. Here actually now the whole throughout the body it will appear anywhere, but particularly in like the brain, if it is it appears in the brain means because in the output no sudden. What is the effect of this AVM? No sudden death only because it will blast anytime it can blast like that. Okay, so we can use this kind of fuzzy cluster approach. Actually, we have used the latest thing, fuzzy cluster that we have used. It's like a machine learning, one type of approach. So we can use because in brain surgery, if you take like a main part of a brain surgery, many surgeries and all those, it depends upon full like a brain surgery means through microscope only we can do it. Even like a heart, if you take like a heart part, we have to consider that it is like a block, everything knows through angiogram only. So like angiogram also in angiogram also we can apply the fuzzy cluster. So here actually that AVM we have to find the optimization level, whether how far it's like a spread. It's like whether minimized, we can minimize. See, this is all already existed one only, but if we can't give the proper solution for them. But we have to predict. So this much level, if you give that what is like a medicine, no. So to predict this kind of AVM, so we can only predict using these techniques. But prediction is like a main part. Once if you find that the prediction technology, all those things and all, we can easily cure many diseases. Correct. So like that. And reinforcement, because here actually I didn't fully explain like a reinforcement learning. So it because it's we have to think fuzzy we can apply for the reinforcement learning or not. So that research actually is going on because once it suits me, I have to consider that reinforcement learning with fuzzy. Okay, and till now actually I have used only for unsupervised and supervised learning in machine algorithm because that unsupervised in the sense we have applied regression as well as linear regression techniques. And unsupervised learning, here we have applied the clustering, that also especially k-means cluster. So we have applied. So recently we have developed a project proposal for to optimize the AVM as well as optimize the brain tumor like that. So similarly, just we are doing the research under that machine learning in what ways, because in many just I'd like to tell the applications of machine learning. So you people also you can try one application because I have told these are the main applications. So this is the thing. So we have to take one by one. So medical diagnosis I have told like AVM and brain tumor like that. And similarly, stock market trading. Now it's very, very important for stock and shares, correct? So how much where we have to invest. Even here, if like all the accounts, everything, no, they will put it, all the banks, everything, they put it in the stock market, correct? So it's kind of some business because it's like it will give like a no through like entrepreneurship also. Individually, we can do it in online access only, everything. But we have to learn the basic for the stockholders. What is the technology behind and what is the tactics actually when that starts, no, so because it's like a fraction of a second, it will come up and down. So we have to keep on, we have to watch it and everything. Now we can do many analysis through machine learning. We can do many analysis. And so next to my target, actually, I had to extend my research in the stock market trading. And similarly, online fraud detection. Yes, online fraud detection is because many, now we are using like a credit card, like digital thing only we are using, right? So many fraud detect very fraud things and all will happen. Correct. So to avoid those things and also how much we can predict. So the prediction area, everything we can apply with machine learning. So it's very, very important at least to know that we have to be very alert for using those predictions and all. Next, virtual person assistant also we can use this thing. For example, email spam and all. Because in general, sometimes no, we will get many mails and all. But sometimes that what mail actually have sent to the sender, it will go to some spam and all. We don't know whether actually we received or not, correct? But so email spam and all that filtering in the sense. So what is the technology behind that and how far it like and how we can optimize these things and all. So we can use easily like a machine learning, especially in fuzzy approach we can use it. And self-driving cars and all those. So how we can optimize this through you. I think you are very familiar. What is the applications of fuzzy logic? So home appliances, washing machine, fuzzy logic we can use it, and air cooler and everything like so nowadays and all without fuzzy logic is nothing is there like that. It's applications I'm telling. So application is going more, but application because we should not focus into one way of this thing. So parallelly we had to learn because as a researcher, as a mathematician, we had to learn many. So fuzzy logic. So what is the parallel line? So along with machine learning, if you learn, I so similarly we can do traffic prediction. So because it's like a four-way signal if you see, if fuzzy logic only we can apply. So through fuzzy logic, many number of maybe the traffic signals also we can easily we can control. Next is speech recognition, imagine. So this and all we have seen very elaborately. So I don't want to tell much about these things at all. So because these are the areas we have to cover. We have to do research in because why I am telling these things about the real life applications. So if you take one application and one application resources connects, for example, if you take like a stock marketing trading, many things are there. So first of all, we have to be very thorough knowledge in the stock market and what is the input and how much if you invest things, how much you will get and because profit also it will be there, loss also will be there, and also period time calculation. So if you use this linear regression, because supervised learning, unsupervised learning and all, we will how much because in what ways and all we will get the profit. Okay, so we will maximize the profit. Everything we can identify. So that is the main part I'd like to tell. So these are the things actually we can do the research part. So that's why I have all those things ideas actually. So finally, just I will come to the conclude. I will conclude the final part of this thing. So the evaluation among all the crisp as well as fuzzy, we can use like a mesh analysis. And many analysis part is also is there, but still the research at all is going on. So I think yes. So this is the thing what we have developed the models because what models we have developed that I have shown 22, but many models we have developed and now many things is also going on. So once it's like everything one by one. Okay, it will be slowly it will be accepted everything. So one by one we are solving the problems because we have selected the real life problems. Okay, so we have selected the real life problems and we have find a solution for that. So if any doubts,
Hello.
regarding this we can ask.
Yes, ma'am. This is Shivan.
Especially
Is it audible?
No, sir. Yes.
Influenced on the rectal cancer. You have very well.
If any doubts, its audience maybe you can ask.
Hello, ma'am.
Yes, sir. Yes, sir.
Is it audible, ma'am? This is Shivan.
Yes, sir. Yes. Yes. Yeah.
Yeah, your presentation was very nice. You started with the machine language, artificial intelligence, and finally you end with the mathematics. In the beginning, I little bit confused. This and all we cannot do and all because artificial intelligence and the machine language, we thought that it's from the core department, from EC or some other computer science department. Now only I realized that it is a base for mathematics only. Thank you.
Yes.
And can you clarify only two doubts me? Two
Yes.
of my doubts. One is
Yes.
what is the necessary for specification and the total cost we are minimizing and output we are maximizing the economic order quantity and the economic production quantity. And second one is what is the situation for the membership function of triangular Fuzzy number and the trapezoidal Fuzzy number and the pentagonal Fuzzy number. At least some point you can tell me, not elaborately. Because
Yeah. Sure.
Okay. Thank you.
Yeah. Anyway, yes. I will tell. So because the sir asked very nice questions. Anyway, regarding that, if we'll go through some papers and all, you can refer, sir. Maybe because I have done many papers in what sir told, like a classification part and declassification exactly. Because in 2008, 9, 10, and all those 5 years and all, we have developed many classification and declassification. So that time and all, we have used triangular and trapezoidal to optimize total cost and economic order quantity like that. But nowadays, actually, recently, many fuzzy numbers apart from triangular trapezoidal, and here fuzzy instead of type 1 fuzzy, type 1, type 2 fuzzy also just we are developing actually. Already it's existing one only, but intuition stake. So under the fuzzy classification, fuzzy numbers. So intuition stick fuzzy numbers. So those things and are also actually we are developing. So because the correcting in the sense, if you are for what purpose we are applying that fuzzy means we have to optimize because all the quantities, whatever the cost we have taken, sir. So everything is like some kind of precise values only, correct? So if like normal calculations, yes sir, if normal calculations if we do, we will get the result, that's not a problem. But here why actually are using the fuzzy situation? Because in all the situation, even like I will give you, if you give small number of quantity and small number of or point not one also, we can I will give very fantastic results actually by using fuzzy. So for that purpose only we are using the classification everything, because every qualitative data, exact that thing, quantitative data we can define through the normal ways, so it's not a problem. But qualitative data, how we can define the qualitative data? So the main purpose the qualitative data, so we can use the fuzzy thing. So through membership value only we can identify the we can recognize the quality data means qualitative data also, no? So that purpose we have used this. And similarly the declassification process also. So okay, so once we have convert everything, for example, I can easily the washing machine. So input we have given the cloth, everything. Okay, so according to the water, time, everything. So we have to set the timings, everything. So that fuzzy logic we have to apply. So input what I have given the cloth, that also the dirty cloth actually, the dirt, and as well as that water level. So the dirt level is like that fuzzy. I have given that it's the input dirt level. So finally, what is the output? The dirt level will be what? Clean, right? So that is the output. So I have converted the dirt level to many number of fuzzy values. After that, what I have to do, according to that, I have to apply the concept. Okay, the declassification concepts. Okay, that is the main part of the thing. Declassification, we can apply the centroid methods or this one graded mean integration and the largest ranking method we can apply, and sign distance method. So many methods are available. So using that, so for washing machine, we are not apply exactly those methods and all. So the declassification, because water level, it depends upon the water level. It depends upon the detergent level. It depends upon the water level, everything. So according to that only, declassify all things. Finally, what my aim, the dirt will be removed. So how much that dirt? So how much it will be removed. So those things are already output. So this is a very small example I can show. So similarly, you have to develop the higher level of concepts. I hope it's like understood
Okay.
little bit,
Thank
correct?
you.
Yes, sir. Thank you, sir.
Yeah, thank you. Thank you. Yeah, I got it.
Thank you, sir.
Thank you.
Okay. If any other having doubts, you can ask.
Thank you, Dr. Very well explained. Very nice presentation, ma'am. This is Dr. Naresh
Thank
Kumar.
you. Thank you, sir. Thank you. So this is not actually what we have applied, sir. Yes, still we are doing the research in this area. So this is a new approach. So under some 6 students under this, they are doing the projects also, sir. Full-time
Super,
scholars,
ma'am. Super, ma'am. Nice one.
Yes, sir.
Nice
Especially
presentation,
full-time. Okay, sir. Thank you, sir. Thank you so much, sir.
Yeah.
Good afternoon, ma'am.
Yes, sir. Good afternoon.
Ma'am, still I'm zero in machine learning means how to approach the topic machine learning and artificial
Yes.
intelligence. There is any
Yes, sir,
platform
very-
to read it?
Yes, sir. Yes, sir. So many platforms, because what you are telling, like, ma'am, I am in 0 level. So 2, 3, 4, 4, yeah, 3 years before, I was also like that. Sir. I also didn't know anything, sir, regarding the machine learning. But I got a passion. I don't know how I got it. I don't know. But machine learning and data science, actually, I got a passion because every semester, okay, I have taken through Swayam courses. I think you people, you are very know about that NPTEL Swayam online platform courses, correct? So in that way, every semester I have taken that machine learning. Here this time also I have taken essential mathematics for machine learning, and that machine learning techniques I have. This is a 4 weeks course also available. Tamil also, even Tamil language is also available, and 8 weeks course available, 12 weeks available. Even if you go not for exam, but exams is also, if you write the exams with, it will learn good. Or if you don't want to write the exams also, it's not a problem. You opt the course, okay? First you register, you opt the course, and under that, because many IIT professors, they are giving very nice explanations for the machine learning. How far, like, you have applied machine learning in other fields, everything. So it's from that only I have learned, sir. So this is the thing I can give the suggestion how you people are learn the machine learning through Swayam platform is there, and many online platforms, even not even like a Swayam NPTEL platform. Many platforms are there. So maybe you can Atal, like All India over the council, that Atal is also there. So you can you go and register and opt for some courses like that. So you listen, because every week they will give the lecture, and they will upload the lectures, everything. So just you maybe, because I had all learned like that only. Now I have finished around some 5 courses like that, sir. All it's like that more than 70% only I got it. But even I didn't get we are the professors, and we didn't get a time to learn all those things. But even though every week actually they are giving the assignments, everything, every Wednesday. So before that day, we have to read that every concepts, and we have to put the answers to the assignments. Then only just we will get the, because 25% in the internal, as well as 75% they will consider like external. So they will categorize like a silver medal, gold medal, that also, maybe FDP also. So there we can opt for FDP. So both the credits we will get it. We learn some new things also, as well as we will get the FDP certificate also. So every 6 months actually. So you go for that one, sir. So that's like I would like to tell my suggestion, because I had learned like that only. It's a very interesting that the machine learning Tamil is also is there. So it's a very interesting that practical online session is also, hands-on training is also there. Online session is also there. So everything, and every week, they will give some 1 hour session. Maybe you can clarify all your doubts and all. Like IIT professors, those who are handling that like sessions, they will only directly, they will clear all our doubts, everything. So even if like after assignment, we will get many doubts, because they never ever ask like direct questions and all. We have to study and analyze, then only we can answer the questions. So like that only. So but it was very useful. So I have now learned in that way only, because every 6 months I will opt for some 2 courses related to machine learning. First I have taken Python course, because basically before doing that machine learning, you should learn like a Python basic thing. Okay, so after that only we have to go for the machine learning process. So it will be useful. And now just like now also you can go through the essential mathematics for machine learning, sir. So machine learning, if you want to study machine learning, what are the essential maths knowledge behind that? because my aim is to take maths in all over the world like that, sir. So because in each way, without maths, nothing is there, correct? So we have to apply mathematics for all the fields. So that is the, anyway, I almost I reached the success, but still I had to, further I had to develop that also, sir.
Thank you, ma'am. Thank you for the information.
Okay, sir. Thank you so much. Okay, any other doubts?
Good afternoon, ma'am.
Yes, good afternoon, sir. Good afternoon.
How are you, ma'am?
Yes, sir. Fine,
Prakash,
sir. Fine,
this is
sir.
Prakash. Okay, ma'am.
Yes, sir. Yes,
Very
sir.
nice
Yeah, yeah.
presentation, ma'am.
Thank you, sir. Thank
Very
you.
nice presentation and explanation, ma'am. Thank you so much,
Yes.
ma'am.
Thank you, sir. Thank you, sir.
Okay.
So my humble request to all those who are what listen this like a talk or this webinar, really just to utilize in the good manner, because so many applications are there. So if regarding if you have any doubts, I will give my phone number and my mail ID to sir. So like some doubts or you need some guidance regarding this, definitely I will give.
Yes, ma'am. Definitely, I'll give, ma'am.
Yes, sir. Sure.
Sir, please share ma'am's mail ID and the contact number in the chat box, sir. Please, we'll note it down. If we forgot. Thank you.
Yes, any other doubt, participants? Any others? Madam number I posted in the chat box, sir.
No, just I will.
I posted.
Okay, thank you.
Yes.
Thank you, sir.
Please contact any details, madam.
Yeah,
Sir, madam,
definitely it's one of the
shall we wind up officially, madam, the session?
Session. Okay. Yes. What's it? Pardon?
Conclude.
Yeah. Yes, sir. Yes, sir. No, I think there is no doubts and all. People actually
Yes,
don't hesitate to ask the doubts. Whatever the doubts, even sometimes we will think like a silly doubt and all, but it will be very really useful for others also. Anyway, so no doubts when we can conclude, sir. I think they have understood in the clear manner, because two ways we can take, whether they have understood in the good manner or I don't know, or the other thing. Okay, sir. Yeah. You conclude.
it is a very
Yes,
useful,
sir.
madam.
Yes, sir.
Yeah, full understood.
Okay, sir. Thank you. Thank you,
In
sir.
the
Thank you.
beginning of upright machine language and all that there is some relation machine language, artificial language, and fuzzy optimization technique. All these it's from the mathematics video and the upward. Thank you.
Okay, thank you.
Now, I conclude this session with a vote of thanks. Thank you, ma'am. Thank you so much for your excellent presentation. You have explained everything clear and sufficient information about fuzzy interpretation and its applications. Once again, thank you, ma'am. I extend my thanks to all the participants. This session is over. The next session will start at 2:45 p.m. Thank you.
Thank you all. Thank you once again, sir. Thank you, sir.
Thank you, madam.
Thank you.
Thank you, ma'am.
Please.